Okay, after we present the problem this paper is going to address, let's move to what's a research question, or what are the research questions to answer? Why do we need this? Not all paper need this, because if your paper naturally addresses a very mathematical, theoretical thing, then people know that, okay, the whole paper is about mathematical equations and algorithms. Of course, you're addressing research. However, for some other work that's more application driven, like some of my research, I designed a solution to deal with Friesenberg for Parkinson's disease. Some people may say, hey, is this programming? Is this software development, or this is research, right? We have to make sure and tell people exactly that we're doing scientific research. We're not just in developing a system and doing coding that a company can do, right? We're doing research, design something to solve something that doesn't exist. So if the topic you're working on has the risk to be challenged, to be engineering, no science, the way you address is to ask a research question. So how many research questions to ask? Typically one, at most two. If you have too many, well, that probably should be multiple different papers. I typically suggest one, at most two research questions. Those are strongly correlated, because we're going to answer research question, and answer to that will be paragraphs and sections and the main content of your paper, right? So another point is that each of the research question has to be a question. I encountered before that some students describe things to say, okay, I want to design something that can detect the Friesenberg gate. I want to use wearable sensors. So they describe with a mouthful of sentences and words, but it's not clear. You do want to make it clear with just one sentence. So to challenge your analytical thought, how can you change your description of 5-10 sentence or paragraph into one sentence that ends up with your question mark? I will give you example later, okay? And then you also need to avoid the binary research question, because a binary question, I give you example. How can we design accelerometer-based solution to detect Friesenberg gate? That's a research question. That's binary. The answer is yes or no. So why binary is not good? Because if the answer is yes, what do you present in the paper? If the answer is no, you prove it cannot be done. So it's better to ask non-binary question to say, how can we design, rather than can we design, how can we design a wearable sensor system to detect Friesenberg gate in real time? Then the answer to the how will be, I propose, let's go to that goes to the next slide, proposed solutions. So you could say, in order to answer the research question on how to design a wearable accelerometer gyroscope-based sensor system to non-intrusively and accurately detect Friesenberg gate in real time. In order to answer that research question, we propose wearable hardware, and then we also propose a digital signal processing on the hardware together with deep neural network models to detect Friesenberg gate in real time. You see, in order to answer research question one, I proposed a sequence of novel digital signal processing that will be explained in section 3 of the paper. In order to answer the second research question, I proposed a neural network, novel one, and I evaluated, which shows 20% of performance enhancement. Then this gives you enough room to present your solution. your solution are scientific sense. They're digital signal processing, they're algorithms, right? Then people, you use that to answer research question, people will not challenge you and say, this is engineering work, this is science. And you show what scientific research question answered and with what kind of computing solutions. So the proposed solution is a key paragraph or the key paragraphs, depends on how long you need to elaborate, right? So you summarize what are the main contributions of your paper, given the context, the problem, big context, small context you have established so far. So this is the most important part of the introduction. Basically, it's a solution. You have to explain clearly to people, as well as what science it addresses. Let's come to look at one example. Also, this paper, okay, Fraser Gate detection and treatment. I will post the paper on the class website. You can also search it online. You can find the paper on my William & Mary academic website. So this paper is free to access for non-commercial, non-profit reason. Okay, you see here, we said the small context stopped here. We need something, right? Now, the research question could be a separate paragraph, and it could also be merged with other paragraph. Here, I merge it with a small context of the problem paragraph. The need for such system needs us to a main research question. I only have one. How can we accurately detect and treat Fraser Gate events in real time? It's clear. I'm not using a whole paragraph to describe the research issue. I use one sentence to articulate the research question, and it does end with a question mark. And it is not a binary research question like, can we? It is, how can we? It's better to always ask, how can we? And I also use bold fonts to emphasize this so readers doesn't miss that. Okay, then you see, to answer this research question, we develop a closed loop, non-intrusive, and portable FOG detection and treatment system. We develop a system in order to answer this research question. It consists of IMU sensors, smartphone, vibration device for intervention. Then that's a overall description of the system. Then we go to more details. To accurately detect FOG, we first generate additional time sequence features. We have scientific features to address different ways patient can phrase. We transform our time sequence feature into frequency domain features. Those are scientific results. We have time sequence features, we have frequency domain features using separate butterworth filtering. Those are digital signal processing techniques to extract information for frequency bands that dominate normal gate cycles and FOG events. We then use multi-input convolutional neural network models, that's science models, to answer this research question in order to allow our model to capture patterns within the normal gate frequency band and the FOG event frequency band. Okay, that's our design. In order to further answer this research question, we can also add a paragraph to say how our solution works. To evaluate our system, we collect data from 11 Parkinson's disease PD patients from 2021 in an IRB-approved study. Now it's end of 2023. It's 2 years data collection. To the best of our knowledge, our data set is the most FOG-rich full IMU sensor data set. This could also be a contribution that will be useful for the research community in the future as data set. With over 700 clinically labeled FOG events, our data set was designed to capture a wide variety of FOG events from 5 most common FOG triggering scenarios. We evaluate our work, the FOG Finder system, against other real-time detection and treatment system. So we compare with state of art using our data set and demonstrate that our system provides a significant performance boost, like 13.4% higher F1 score. Basically, it's more accurate. And 10.7 higher overall accuracy over existing ones. The treatment system in a leave one subject out scenario. Leave one means that I train a model on patient A, but I applied and tested on different patient B. So basically, these two paragraphs answer the research question in terms of how I design it with the digital signal processing and with the modeling. And I also evaluated with data set, and it shows superior performance. I answered my research questions. Okay, let's stop here.